Seventh grade, point-slope form. Point-slope form is another way we can graph a line given a certain type of an equation that looks a certain way. Now, we've already looked at slope-intercept form, and when we looked at slope-intercept form, what we had was a slope and an intercept, specifically the y-intercept. So it shouldn't surprise you that when we have a thing called point-slope form, what I'm about to give you is the point and the slope that's on that equation there. So, we have to make it look this certain way in order to use point-slope form, just like we had to make it look that certain way to graph slope-intercept form. You can't just write it any old way and say, oh, well, that's it. That's all I need. I'm going to go ahead and just graph it looking like that. That doesn't exactly work. You can get away with that for table method, but because remember, table method works for anything, even if it's not a line. All right, it has to look this very specific way to graph point-slope form. And that's the first thing you're presented there underneath the concept of general form. Y minus y sub 1 equals m times x minus x sub 1. Now, it's explained to you there what those different things mean. M continues to represent slope, just like it did in slope-intercept form. So there's nothing new happening there. X and y, as you know, x and y, no matter what type of equation set we're going to look at, those are always just going to say x and y. So I don't really have to think too hard about what that's going to be. X and y is always going to be x and y. X sub 1 and y sub 1, that's the x and the y with little ones after them. That represents a point that's on the line. Because it has minus in front of it, though, it's treated like it's read as the opposite. So when I have that and I'm looking at it, what I'm really going to end up plotting is what the opposite of how those look. And that's really all you've got here for point-slope form. You've got slope, m. You've got a point defined by the opposite of x sub 1 and the opposite of y sub 1. And we'll plot that, and that's all we need. So it describes next there on the screen how to actually do this. All right, you're going to plot the point defined by the opposite of x sub 1 and y sub 1 as pictured. The x value is in the x block. The y value is in that y block. It's really easy to remember. X value is right next to x. The y value is right next to the y. All right, now, once you plot that point, and remember x values go on the x-axis, the one that goes left to right. The y values go on the y-axis, the ones that go up down. Once you plot that point, then you're going to go ahead from there and move on to step 2, which says then plot the slope. Now, slope still has the exact same meaning, even though it's a different equation. So slope is still talking about rise and run. How much a line changes moving up or down, and then how much a line changes moving to the right. So once you plot your point, you plot your slope. Again, your slope from that point you just plotted, you're going to go up or down and then to the right. And then you'll have your second point, you connect your 2 points, and you're done. So let's look at the example here that's thoroughly explained before we go into our independent practice here. The question they've given us here is y minus 3 equals 3/2 times x minus 4. All right, so the first step there tells us to plot the point defined by the opposite of x sub 1 and the opposite of y sub 1 as pictured here. So, again, that point you need is matched up with its partner. Okay? We look at the x block, which is this x set of parentheses over here, for the x information. Now that looks like -4. Remember, as it says here, I'm plotting the point defined by the opposite of that. So if it looks like -4, the x value I'm going to end up plotting is going to be +4. Then I come over here and look at the y block. In the y block of values, remember points are written x comma y, so I need both. In the y block, that looks like -3. So I'm going to plot its opposite, which is +3. So the first thing I'm going to do is plot the point 4, 3. Traditional graphing. Go to 4 on the x-axis, 3 on the y-axis. Those two meet right there. So that's going to be my first point. All right, now let's go down to step 2 here. In step 2, they're asking me to now, from the point I just made, 4, 3, plot the slope. So I'm going to go to 4, 3 that I already had. Just going to re-sketch it on my little graph here. And my slope here is that thing that was in front of the x values, the thing that was right after the equal sign. Well, that's sloped instead 3 over 2. Well, that's great because it's already written as a fraction. Remember, slope has to be a fraction because it's got to have rise and it's got to have run. So if it's not a fraction, you're going to make it a fraction. But this one is already a fraction. Slope says 3 over 2. So that means I'm going to rise 3 and run 2. And when you do that, you go from the point you already made. So from this point here, I'm going to go 3 jumps up and 2 jumps to the right. And that's where I'll land my other point, and I connect, which is what step 3 tells us to do. And there's the graph of my line. What sometimes people do that causes them to make a mistake is they come back to the origin, and from here they would rise 3 and run 2 and put their other point connect. You don't do it that way. You go from the point you've already made your slope. So you'll either go up or down depending on what the rise is, and then to the right for the run and plot your other point and connect. In this case, since it was 3 over 2, from that point we already made 4, 3, we went up 3 jumps and 2 jumps to the right and put our other dot and connect. All right, so let's go ahead and continue on here and take a look at the examples. Now, there's not really any variation in what you're about to do here in the examples. It's just all about graphing point-slope form today. No story problems, no mixing it up, no real tricks here, anything about this. It's just graphing in pure point-slope form. So we go ahead and take a look at the first one here. It says y minus 5 equals 4/7 times x minus 1. So first thing I want to do is find the opposite of the x point and the opposite of the y point because that's the point I'm going to plot. Remember, the x point you need is with the x. So look in that x block there. All right, in this x block here, it looks like it says -1. So I'm going to plot the point 1. All right, its y value that's going to match up with it, that's over here. Notice this says -5. Looks like -5. So I'm going to plot its opposite, which is 5. So I'm going to plot the point 1, 5, which means from here I'm going to go 1 on the x-axis and 5 on the y-axis, and where they meet is right here. Put a dot. Now my slope here is 4 over 7. Again, slope is always right after the equal sign. It's in front of that x block. So slope of 4 over 7, slope still has the same meaning it did the other day. Slope of 4 over 7 means I'm going to rise 4 units and then run 7 units. Meaning I'm going 7 units to the right. 2, 3, 4, 5, 6, 7. So from the point I already made, I went 4 jumps up and 7 jumps to the right. And I'll connect my points. And there's the graph of y minus 5 equals 4/7 times x minus 1. All right, let's try number 2. Y minus 3 equals -1/4 times x plus 2. So again, start off, I'm going to plot my points, x comma y. The x value that I need is in with the x block of information. So if I look at this x block here, it says +2. Well, remember, I want its opposite, so I want -2. Come over to the y block for the y piece of information you need. Well, it looks like that says -3. So I'm going to plot the point 3. So I'm going to plot the point -2, 3. Left 2, up 3, put a dot. All right, now my slope here is -1/4. A slope of -1/4 means I'm going to rise -1 units and then run 4 units. So that means in this case I'm going to go down 1 jump because it's -1 and then go 4 jumps to the right. Again, slope still has the exact same meaning it has in every other section. So from here I'm going to go down 1 jump and then 4 jumps to the right. And when I land at that place, I'll put my other point, connect my points. Notice here, slope was negative. The line points down. Remember, this is a negative slope. Any line that goes down from left to right has a negative slope, so that makes sense. Just like over there in example 1, the slope 4/7 was positive, which shows us that the line points up from left to right. All right, let's go ahead and continue on by taking a look at examples 2 and or rather examples 3 and 4. More graphing of point-slope form. In number 3, we're asked to graph y plus 2 equals 5/3 times x plus 5. All right, so first off, I'm going to grab my point here, which is, again, always x comma y. And for the x piece of information I need, I'm going to look at this x block of information here where it says x plus 5. All right, what you're going to do is look at what it says. It says plus 5 or positive 5, and you're going to write down the opposite of that, which is, of course, negative 5. And that's going to be your x coordinate. For the y coordinate, I'm going to come over here to the y block of information, and I look and it says y plus 2. Well, it says plus 2 or positive 2. Well, its opposite is going to be negative 2. So my y coordinate is negative 2. So I'm going to put a dot at negative 5 comma negative 2. Negative 5 on the x, negative 2 on the y. They meet down here in quadrant 3. Some of you might be wondering, why is it always the opposite? Why is it always the opposite? Well, we're actually solving here for x and y. Notice here what we've graphed, x and y. All right, well, that is what makes each one of these blocks equal 0 when I use the opposite. Negative 5 plus 5 makes 0. Negative 2 plus 2 makes 0. That's called finding the zeros, which is something you'll study more later on. But that's what we're doing here. We're actually finding x and y values that make each one of these blocks equal 0. That's why it's the opposite. Negative 5 plus 5 makes 0. Negative 2 plus 2 makes 0. Okay, now I'm going to plot my slope here. My slope is 5/3. Slope of 5/3 means I'm going to rise 5 units. So from this point over here in quadrant 3, I'm going to go 1, 2, 3, 4, 5 up. And then the run here is 3, so I'm going to go 3 units to the right. 1, 2, 3. And I plot my other point, and I connect. All right, let's take a look at number 4. Y plus 3 equals 3 times x minus 1. All right, so start off here. Let's grab my x comma y point. Remember, the x value is in the x block of information right here. And notice it says minus 1, or negative 1 if I cover that up. Well, I want the point that's defined by the opposite of that. So I really just want 1. Then for the y block of information here. Well, when I come over for the y coordinate, I look at the y block. It says plus 3, positive 3. So I want the opposite, which is negative 3. So I'm going to put a dot at 1 comma negative 3. To 1 on the x-axis to negative 3 on the y-axis, those two meet right there. Now, slope. Slope here is 3. Remember, slope always has to be a fraction. It has to represent a rise to run relationship. So if it's 3, what they really mean is 3 over 1. That means I'm going to rise 3 and run 1. You know by now that we can take any whole number and put it over 1, and that would be its fractional representation. That's nothing new. So slope here that turns out to be equal to 3 over 1 means I'm going to rise 3 units, go up 3 units, and then go 1 unit to the right. Positive rise goes up, negative rise goes down. Then I connect my points, and there's the graph of y plus 3 equals 3 times x minus 1. All right, let's go ahead and take a look at the last example here, number 5. In number 5, we've got y minus 9 equals negative 1/7 times x plus 0. So let's start off with the x and the y block here. Again, for the xy coordinate I need, the x coordinate comes from the x set of information in the question. The y coordinate I need comes from the y set of information here. So for the x block here, now in x, what's different about this one, which is something you'll see in the homework as well, x just says 0. Well, you know by now that 0 doesn't have an opposite. So if it's 0, the x coordinate I'm going to plot is still going to be 0. There's no such thing as positive 0 or negative 0. It's just 0. All right, y coordinate, a little bit more clear. The y coordinate is over here with y. Notice it says minus 9 or negative 9 when I cover up y. Well, the opposite of that is 9. So I'm going to plot the coordinate 0, 9. Not right or left, just up 9. Then I'm going to plot my slope. My slope here is negative 1/7. Slope of negative 1 over 7 means I'm going to rise negative 1 unit, or in other words, go down 1 unit. Negatives go down, positives go up. Again, slope has the exact same meaning it's had in every section you've seen in a presentation. Down 1 unit. And then run 7. Go to the right 7. So I go 1, 2, 3, 4, 5, 6, 7 units to the right, and I connect my points, and there's the graph of y minus 9 equals negative 1/7 times x plus 0. Again, no variation in this tonight. You're just all graphing in point-slope form. No story problems, no mixing it up, no little tricks, just graphing.